Next, we look at case 2. And in this case, we have 3x squared plus 2x plus 1 over x plus 1 times x squared, x minus 2 squared. So how do we decompose that? So case 2, we have 3x squared plus 2x plus 1 over x plus 1 by x minus 2 squared. And we said this can be decomposed into a over x plus b over x plus 1 plus c over x minus 2 plus d over x minus 2 squared. And the right hand side can be simplified, and we have it as a x plus 1 by x minus 2 squared plus b x bx times x minus 2 squared plus c x plus 1 times x minus 2, and finally d will be x plus 1. And we can show that it is congruent to 3x squared plus 2x plus 1. Now we have four constants. So we can use the same method as case 1, but sometimes it doesn't work. For example, we can say let x is 0. If we let x is 0, the whole of this will be 0, the whole of this will be 0, and the whole of that will be 0. Yeah, remember x is 0. That means we will only be left with a. And therefore we shall have x is 0. The left hand side will be equals to 1. Is equals to, remember x is 0. So this one will be a, 0 plus 1, and 0 minus 2 squared. And this will be a times 1 times negative 2 squared, which is 4a. So 1 is equals to 4a, and therefore a is a quarter. So what else can we make x to be such that either we eliminate a, b, c, and we are left with only 1. Note, if x is, let's say 2, if x is 2, this one will be 0, this one will be 0, this one will be 0. In other words, a will be knocked out, b will be knocked out, c will be knocked out, and we will be left with only d. And this other side will be 3, 2 squared plus 2x is 2 plus 1 is equals to d times 2 times 2 plus 1. 2 plus 1. And this on the other side, 3 times 2 will give us 6d. On this other side, we shall have 4 times 3, 12, plus 4, 16 plus 1, 17. So we have 17 is equals to 6d. And therefore d is 17 over 6. So we have a, we have d. We need to get b and c. Now we can do this. We let x to be negative 1. If we let x to be negative 1, a will go, because this will be 0. If x is negative 1, c will go, because this is 0. And of course d will go, because that will be 0. And we shall be left with b. So we shall have on the left 3 times negative 1 squared plus 2 times negative 1 plus 1. So b will be b times negative 1 times negative 1 negative 2 squared. And this will be the same as negative 1 negative 2. That's negative 3 squared is 9 minus 9b minus 9b. And on the left we have negative 1 squared is 1, 3 plus 1, 4 minus 2, 2 is equals to negative 9b. And therefore b will be negative 2 over 9. Negative 2 over 9. Now we have A, we have B, and we have D. Our issue is to get C. And you see now, this is the point I was saying. Letting x to be a certain value, and then you try to eliminate the rest, might meet some obstacle. Because now, what can we make x to be such that the rest disappear and we are only left with x. Of course, we know A, we know B, we know C, we know D, and B. So the method that works for such cases, and maybe the other cases, case 3 and 4, is to expand everything on the left hand side and on the right hand side, and then you equate the two. So this on the left is clear, 3x squared plus 2x plus 1, and on the right, if we expand all this, we shall get ax plus 1. Maybe first expand x minus 2 squared, so that's to make our work easier, plus, I think we can expand this right away, x squared, that is x cubed, minus 4bx plus 4, this should be bx squared for 4bx, and then the other one should be cx. Let's expand the first one, x squared, that is minus 2x plus x minus x minus 2, and then dx squared plus dx. So this should be A, and remember A, you are multiplying with everything. So this should be A by x cubed minus 4x squared plus 4x plus x squared minus 4x plus 4 then plus bx cubed minus 4bx squared plus 4bx plus cx cubed minus cx squared minus 2cx plus dx squared plus dx. So we can arrange them starting in the one with x cubed, because 4x, this one will cancel. We can have the x cubed, so the x cubed we have A, we have B, and we have C. X cubed. Remember, since I have A and B, I can ignore the other process of, let's say, having the x squared here, that is minus 4, then this one, sorry, this is x cubed, s squared minus 4x is minus 3x squared. Remember by a, minus 4b, there is an a here, minus 4b, this one, and then minus c, everything x squared. So the x squared are done, that one, that one, that one. So, and then we go to the x. The x, we have 4b minus 2c plus b x, and sorry, x squared, we forgot this one, so we need to add plus d here, then the constants we shall have 4a, I think that's the only constant. 4a. So the constants on this other side is 1, the 2x term, and the 3x squared. Note that the x cubed, the coefficient of x cubed is 0. And that's why I was saying, since I used this method to get a, to get b, and to get d, and since here I have ab plus c, x cubed, I can ignore the rest of this. And what I'll do is take a plus b plus c is equals to 0. Note that on the right hand side, the coefficient of x cubed is a plus b plus c, and the coefficient of x cubed on the left is 0. But already I know a is a quarter, and b is 2/9. C, I don't know. So from here, it's clearly that C is 2/9 minus a quarter, which is the same as 8 minus 9 over that 6, 1 over that 6. And when I get that, it is easier for me to write these partial fractions using those constants a and b.